Alright, so I talked a little bit about composite solids or composite volume when creating the graphic organizer on the other video. So I just want to kind of touch back and make sure we get some examples in with that. So you should have an assignment with you that has these examples on it. And I'm not going to work each one of these because this is your classwork, but I'll just hit a few of them. So since I'm going to do one like number 1, but further down the page, I'm not going to do that one. I'll leave that one for you. But we'll go ahead and look at number 2. So for number 2, you should first identify what 2 figures you have. So on the top here, you should notice that that is a pyramid. And then on the bottom here, you should notice you have a rectangular prism. It's a terrible S, but that is an S. Alright, so we have to actually find the volume of each individual piece, and we need to add them together, or each individual figure. So the first one, for a pyramid, we should look at the volume formulas, and we should see that it's 1/3 big B times H. So remember that you need to identify what your big B is, and remember big B is just like the bottom of the pyramid. So if we kind of imagine the bottom being in here, I'm just kind of drawing it in what it would look like. There'd be a line back there somewhere, but that bottom of the pyramid would be the same as the bottom of the actual prism, rectangular prism, because it's sitting directly on top of it. So if the top is shaped like a rectangle for the prism at the bottom, then also the bottom is shaped like a rectangle. And I'm saying a rectangle down there, but actually if you look at the side lengths, you should notice that it's 4 inches by 4 inches, which means it's actually a square down there. So if, well, I'm letting that car pass. I'm in a car. You guys, I'm in a car. Look at this dedication right here. I'm in a car. So you guys better do your work regardless. If you're in a car, on a bus, in the classroom is where you really should be doing it right now. But yeah, hear this dedication, you hear these cars going by? Anyways, back to work. Like I said, no excuses. So the bottom of the pyramid is a square, so our big B is a square. And you may look at the sheet and you're like, oh, but there's not an area formula for a square. Well, remember, a square is a rectangle, folks. So the area formula for a rectangle, because our big B is a square, which is also a rectangle, the formula is little b times little h, which is just the base and the height of that square there. Well, in this case, it's a rectangle, but it's a square. So it's a rectangle formula, but it's a square. So that times that, because remember, you're getting it off of the square at the bottom of the pyramid, which is why it's our big B. It's the bottom of our pyramid. So our length and our width, our base and our height of that square, you just pull it out, it's a 4 by 4. So remember, when you're doing the area formula for your base, those numbers have to come off the base. So that's telling you right there, this 6 has nothing to do with that square. That's the height of the actual pyramid. So make sure you're using the right numbers. So it's just simply 4 times 4, which equals 16. Or in this case, it's inches, and it's area, so it's inches squared. So right there, we know our big B is 16 inches squared. Remember, you cannot just get big B off of the picture. It's not going to be a number off the picture. You have to calculate it. So the volume for our pyramid is 1/3, then our big B, which we just found to be 16, times the height of that pyramid, which is 6. So if we calculate that, we will should get 32 inches. Remember, this is volume now, so it's cubed. 32 inches cubed. So that is the volume just for the pyramid. So now if I do the volume for a prism, remember, volume for a prism is the smallest volume formula there is, which is big B times H. Well, as I mentioned earlier, the base of the pyramid, which now I'm drawing in red, is the same exact size and shape as the base for the rectangular prism. So we already found big B for that as well, because they have the same big B. So our volume for the prism is our big B, which we found to be 16, times the height of that rectangular prism, which the height, how tall it is right there on the side, it's 5. So 16 times 5 is 84 inches cubed. So remember, don't be a sucker. Don't just look on a multiple choice test over at the answers and see a 32 and grab it, or see an 80 and grab it. Remember, you have to look back and see if you answered the actual question, which was to find the volume of the composite solid. So now you have to actually add them together because they are joined together. So if we add 32 and 80 together, we get 112 inches. Oof, that's ugly. Let me just fix that. 112 inches cubed. So that is the volume of the entire figure. So remember, you're just adding the two separate volumes. It's like two problems in one. You do them both and then you add them together. Don't make it like super different. As long as you understand how to do one separately, then you should know how to do one together. So I wanted to just do one towards the bottom just so you can kind of get a feel of each different type. Looking at number 3, I'm not doing number 3, but look at that. Notice you have two different figures there. Find the volume of each. Notice the bottom is not an entire sphere, so you're going to have to actually, think about that one, an extra step on that one, which I'm not going to reveal, but you should know. But I want to look at number 4, because number 4, it's showing the bottom is an open hemisphere. That means basically, like, if you imagine almost like a cup or a bowl upside down, it's going to be an open space in there where this sphere is. This is all open space right here. So it's not filled in, it's open. So we're actually going to have to subtract this time because it's not sitting on top of it, adding to it. It's like kind of like caving in right here. So we're going to first identify our figures that we have. Here we have which you should see, a cylinder. Not a cylinder. Gotta erase that. What am I writing? A cylinder. Alright, so we have a cylinder up there, and then at the bottom we have a hemisphere. Remember, a hemisphere is just half of a sphere, so we're actually going to have to find the sphere's volume first, and then we're going to divide it by 2. So let's go ahead and work from top to bottom. Let's do this cylinder first. If you look at the cylinder formula on the formula sheet, you should see that it's basically your pi r squared, which is the area of your circle base for the cylinder, and then times the height of the cylinder. And that's why it's basically the same as volume equals big B times H, because the big B is that pi r squared. It's that circle. So if we look at that and find that we have pi, well, the radius is not 7. Remember, they're showing us the diameter. And once again, don't be a sucker. Don't let the small details, get you caught up. Make sure you understand what you have. So 7 divided by 2, so that we just have a radius instead of the entire 7. We need to divide by 2, and we get 3.5 as a radius. So that is how we find the big B, which is the area of this circle. And it's the same size circle, so I know I colored kind of at the top there, but it's the same as the bottom. And then we're going to multiply it by the height. So let me first see what we have here with just a big B, which is 12.25 pi. Remember, it's best to leave it in exact form until the very end if you need to round. That way you're not double rounding and basically cutting off some of it. So that's our big B, and then we now multiply it by the height of the cylinder, which the entire height, notice right there on the side, is 5.5. So therefore our volume of our cylinder is equal to, looks like it's 67.375 pi. Alright, so that's what we have for the volume of the cylinder. If you change that to a decimal, it is a decimal with times a pi, but if you multiply it by pi, you get 211, so it's approximately 211 point, I'll just round it 2 decimal places, 0.66. Alright, so that is our volume. It doesn't necessarily have units, so we'll just leave it as is for now. So now if we find the volume of the hemisphere, so volume of our hemisphere, we're going to go ahead and do the volume formula for a sphere, which is 4/3 pi r cubed. So that is going to equal 4/3 pi. Well, the radius in this case, once again, it's the same size circle for the base of the cylinder as it is for that circle for the sphere. So we have 3.5, and that entire volume, if the entire sphere was there, would be approximately 179.59 if I just round to the nearest 2 decimal places, which is the hundredths place. So now remember, we just found the volume of a sphere if the entire sphere was there, but it's not. We're actually only looking at a hemisphere, so we have to divide by 2. Oops, I'm undoing when I should not be. Alright, so we're going to divide this number by 2. That's something if you don't catch and you just start adding or subtracting things, then you're just like getting wrong answers, and then on multiple choice options they will have that wrong answer there, so make sure you're focused on that, the details. So once you divide by 2, you get 89.79, but that 7 behind that 9 is going to round it up to an 80. 80. Alright, so now we have our 2 numbers, but you must pay attention because this is the cylinder, this is the hemisphere. We're actually taking the hemisphere out of, so this is once again open and kind of like grooved in, so we're taking that out of the cylinder here. So let me pause because it's getting real noisy. Alright, so we should be doing 211.66 minus 89.80 because we have to take the hemisphere out of the cylinder, and that is going to equal 121.86. So that would be the volume of this particular solid or figure, because what we have here is we have a hemisphere being taken out of the cylinder. So I'm just going to write that somewhere. I'm going to write it up here. So we have 121.86 units, because we don't have any particular units, units cubed. So that is the volume of that composite figure. Alright, now I just wanted to mention on this one, I mean, these are problems you could think through. If you just take it one step at a time and think through it, you have all the tools in your toolbox. You just got to make sure you know how to use them. Alright, so really do some critical thinking on this problem and the cone problem, because they're both doable. They're just applying it to something in real life. That's it. Obviously you know what shape tennis balls are, I hope, and I hope you know what shape a snow cone is, and the bottom part, that's called a snow cone for a reason. So hopefully you'll be able to figure that out. Alright, so I just wanted to mention a few things about the other parts of the graphic organizer I already talked about, but once again you have to now practice it on the practice assignment for class. As I mentioned before, and actually number 2 is directly off the graphic organizer. So if you have a prism or a different type of solid like this cylinder here that is actually slanted or tilted, it's the same exact volume. You'd use the same formulas no matter what, because if it has the same exact size base, so if we have a radius of 5 circle over here, and in a cylinder off of that, that's 12 units tall, no matter if it's standing up straight or slanted, it's still going to have the same big B, same size big B, and it's still going to have the same height. So no matter what, those things are going to go in the formula, and it's going to come out with the same exact volume. So just calculate those the same as you would. Just identify their shape, identify their base shape, find your big B, and proceed as normal. Slanted or not, Cavalieri's principle tells us that the volumes will be the same. Slanted or not, the volumes will be the same. So calculate as normal. Alright, same thing even with these on the bottom there. This is just turned. So look at what shape it is. Hopefully identify as a cone. Hopefully identify the base as a circle. If the entire thing across is 6, then you should know what my radius would be. So that's my base shape. Find my base shape, my big B, and then you have your height. So yes, it's tilted on its side or slanted on its side, but just imagine standing it up. Alright, so do those. I wanted to mention this as well. This is the last thing that's on your graphic organizer, which is talking about cross sections. I kind of just talked through it yesterday, but didn't really give you guys any practice on it because I wanted you to first re-practice what the volume formula is. But just talking about the cross sections, basically if we are cutting it vertically, you got to imagine cutting it up and down. If we're cutting it horizontally, you got to imagine cutting it left and right. So do that for each of these solids and identify what shape it would be. I'll do it for a few of them. Like for instance, the first one, if I cut the sphere vertically, if I cut it with some type of sheet, maybe like a metal sheet, it would definitely make, ooh, that's a terrible drawing on my sheet. Hold on. Let's do that again. I know what it is. My sheet is too little. Okay, so if we cut it, basically, we just know if we're cutting it up and down, it would be also a circle. Alright, if we cut it up and down, it would also be a circle. As if you could see left and right. Well, cutting it left and right, you see the circle here. So if you were able to actually open this up and look at it, kind of like a Pac-Man mouth, you'd have a piece like that. Ooh, that looks really crazy. Looks like you can't write on this thing. And a piece like this, kind of like an Easter egg. You'd open it up, but the point is you'd be seeing a shape right here that was a circle. So that's no matter how you crack it. So this way it's going to be a circle. It says draw the vertical and horizontal cross section, so I'm just going to draw a circle this way, and then horizontally it'd be a circle as well. Alright, I'm kind of drawing a flat circle because I'm trying to leave it three-dimensional. Now when you do your rectangular prism, imagine slicing it. And one thing you can do is just, if you're doing it vertically, for instance, follow the lines vertically. If you sliced it vertically, if you follow the lines, you'll see it's actually the same exact size and shape as one of the ends that are going vertical. It is one of the same, that's a vertical side, so that is like a vertical slice. That shape right there is a rectangle. So if I drew the rectangle, once again, just keeping it in 3D world, it would look like this. Now you don't have to draw it keeping it in 3D world, but that's it. If you have to slice it horizontally, well, if you slice it horizontally, you just kind of follow the edges here, you should see you'll get a rectangle. Well, where is that rectangle? It's the same exact size and shape as the already horizontal base. So you can kind of use your horizontal and vertical sides just to see what it's going to be. So that is also going to be a rectangle. Sorry, my handwriting is real sloppy, but it's just because how I'm doing this right now. Alright, so for a triangular prism, I'm not going to do everyone with you, but once again, vertical is just up and down. Find one of your sides that are up and down. Here's a side that's up and down. What shape is that? That's your vertical side. That'll be the same as a vertical slice in the middle. No matter if it's in the middle or on the end, it's still a vertical slice. And then, if you're trying to do a horizontal slice, well, if I followed the edges, I just followed across the edge, all the way around, you should see it's going to make a rectangle no matter what. Well, you already have a vertical side you can use. A horizontal side. This is a horizontal side, and that is the shape of the rectangle. So, kind of just use your sides that you already have. The cylinder may be a little tricky vertically, but if you kind of understand following the edge, like if I sliced it right there in the middle and just drew straight down the side and straight down this side and then went that way, you should kind of see what shape that makes right there in the middle, what that vertical slice would be. Then when you do the horizontal slice, well, you already have some horizontal sides right there. You should kind of know what that shape is. But you'd follow the trend of what's happening. So hopefully you see that. This kind of helps it a little bit because it's kind of showing you if you took like a thin sheet of metal or something and cut it right there, what shape would it be? Well, just imagine following the edge. You can't really see where the other part meets it, but you can kind of think about if you were able to see that side and see that side, that's where the paper would meet the shape. So just imagine slicing these things, opening them up and looking at the face of it and seeing what that shape would be. Alright. Let's see, is there anything else? At the bottom, you're just drawing the shape of the slice, and then you are finding the area of that shape, which you have all the dimensions to do that. So take your time. That's the last little bit. Then you should get your test review after you complete this classwork, and hopefully you are getting this stuff because we have a test on Tuesday. I will be there on Monday if you guys have any questions or if you want to plan to stay after school. I will be there. We'll probably have a little short quiz that I hand directly back to you on Monday, just to kind of see what our strengths and weaknesses are. That way I can hit those during class on Monday. So just so you know, maybe a few questions long, but just so I can see how much you know and how much you don't. That way I know what to cover while we're in class on Monday. All right, good luck. Adios.